Hello YouTube, welcome back to Kind Heart Homestead. My name is Ben and I'm up here on our off-road property in the mountains of Virginia. Behind me are the four corner stakes that represent the inside perimeter of the footing of our new house build. I also have some pins towards the middle that represent the edges of some pony walls that we have. I've kind of been going out with a rake and a hoe trying to make sure that there's no gravel in the spots where the concrete's going. That way, I have a blank slate to install the formwork for the concrete. Before I do that, I need to get the rebar in place. So that's what I'm going to start with on this video, and we'll see what else we have time for. So stick around, and I'll be right back. Well, it's the next morning. Feels pretty close to freezing with the wind chill here. So I'm doing my best to bundle up without putting on my nice clothes, because my next step in the process is to cut a bunch of rebar using cutoff wheels on my angle grinder. It creates a lot of sparks and I don't want to mess up any good clothes. So I have my construction flannel on, some old jeans. I need to get some ear protection and some eye protection on. But as you can see here, I have this roughly laid out. The spacing's not exact. I'm going to use the foothold spacers, and those have hooks on the bottom to hold the rebar in place. So it's not really up to me where the rebar goes. It's going to hold it like 2 inches off the ground, and I think maybe 6 inches apart towards the center. But what I need to do is cut pieces that I can bend to make some 90-degree adapters. Since I have two courses of rebar going around the full perimeter and through each pony wall, that means everywhere that there's a corner, I actually need 2 corner pieces. So 2 here, 2 there. So that's 4 on this side, 4 on the other side, 4 for this pony wall, and 4 for that pony wall. That's 16 pieces. And I think for these outer corner ones, I'm gonna cut like maybe 5-foot pieces. I might need a bit longer, I need to measure. So I'm gonna get into that now. I'm probably just gonna do a quick time lapse of me cutting the rebar because it's too cold for me to be out here talking to the camera. I just need to go knock it out.
Using my Milwaukee angle grinder and a cutoff wheel from Harbor Freight, I'm cutting these rebar pieces down to 4-foot increments. These full rebar pieces are number 4 rebar, and the number is the eighths. So number 4 rebar is 4/8, which equals 1/2 inch. And I'm cutting these at 4-foot increments because 4 goes into 20 foot 5 times. And that means there won't be any waste in the rebar left. There's a trick I developed a couple years ago where instead of renting or buying a rebar bender, I can shove it through the corner piece on the shipping container and use my body weight to bend it. So now let's move on to the placement. I'm putting 2 courses of rebar around the perimeter of this thing. So I need 2 corner pieces per corner. I also need 2 corner pieces per intersection of the pony walls. So that makes 16 corner pieces in total. And this rebar is relatively easy to bend at 1/2 inch. I don't think I'd be able to do this with thicker rebar without the appropriate tool. But one thing you need to pay attention to when you're splicing rebar is the overlap. And I'll explain that just in a couple minutes. Check out this aerial view of the rebar in progress.
Behind me is the site of our future house. It's going to be about 800 square feet on the first floor and the second floor. It does look pretty small, but I've heard that anytime you're excavating and getting ready for a house, the footer's poured, the owner always says that it looks too small. Granted, this is going to be a pretty small house, but 1,600 square feet should be plenty of room for us 3. It's going to be a 4-bedroom, 2-bathroom. So I think it's going to be plenty. And I want to encourage us to spend more time outside. So I don't want to have massive rooms where we're tempted to just kind of throw all of our stuff around in there and just like be lazy. Anyway, it's been a while since I've worked on this. You can see the area where the footing is gonna go is starting to get some plant life. I need to blowtorch all that stuff away because we can't have organic material there. It's going to affect the compaction of the soil. But while I'm out here today, enjoying this nice warm weather, even though it's overcast, I need to start cutting that big stack of foam board into little strips to act as the form boards for our concrete. I'm going to use the foothold system, which I've explained in previous videos. I might touch on it again, but I basically have to construct forms. They're going to be 8 feet long each, and I can carry them over and just set it right on top of the rebar. Then I can lift the rebar up and hook it. I have no idea what to expect with this. I've never used the system before. So you're going to learn while I learn. So stick around and I'll be right back.
To prepare for building the foothold system, I first need to rip down some of these foam boards. These came in 4x8 sheets from Lowe's, and these are the 2-inch thick variety, which I believe is the thickest you can get at the local hardware stores. I think it's an R10. It's not really that important for insulation because this is a footing that's going to be down below the frost line. But in order to transport them, I brought my battery-powered Milwaukee table saw that you see down here to the hardware store. I suppose I could have went ahead and ripped all of this down in the parking lot to the appropriate amount, but just for safe transportation, I just ripped each down the middle. So I had 2-foot strips instead of 4-foot strips, and that just packed a lot easier. I had to keep the tailgate down in our Ford Ranger, but having 2-foot pieces standing vertically is a lot easier to move and maneuver than 4-foot pieces standing vertically. I have transported 4-foot pieces before, and that was kind of a hazard. I don't really have any visibility out of the back window, and then it also sticks out above the cab, so there's a lot of wind resistance. One trick I like to do when transporting foam is to line it all up into one big block and then strap it all together, so it's just one piece. And then once that entire assembly is set up as one piece, then I strap that whole thing into the truck. So it kind of has multiple ways of being held down. Now the next step is to put the plastic webbing pieces on the foam. The instructions say to have these evenly spaced. I believe it was 16 inches, but you start 4 inches from the edge. And then it says to put in a 3-inch screw. I didn't have any 3-inch screws, but I have an entire box of 2.5-inch screws that were left over from a roofing project that I was doing at our old property in Raleigh. These actually work just fine because the webbing is flexible and it digs into the foam just a little bit, not so much that it needs to destroy the foam, but just enough to hold it in place and allow the screw to protrude through the other piece and hold it in place. These screws aren't really structural because the foam is going to fit inside of those things perfectly. But what the screws do help with is the foam from sliding up or down along the inside of those plastic pieces of webbing. What you can see here is that I didn't rip the foam full depth. Instead of 10-inch pieces, I ripped 8-inch pieces, and I aligned it with the top instead of the bottom. And I regret doing this just a little bit, but it was necessary because our ground was not perfectly level. If we were doing form boards that were made out of wood, I could potentially scribe the contour of our terrain onto the board and then custom cut it. Sure, that would be a waste of lumber, but it is possible. You can't really scribe the foam when you have these plastic pieces in place. So I kept them 2 inches off the ground, so anywhere that the form needed to be lowered, I could just dig a small hole in the ground where each of those pieces of webbing touches the ground. That way I don't have to dig an entire trench. You may have noticed on that last one that I accidentally put some of the foothold plastic webbing pieces upside down. I eventually realized that when I went to put the rebar in, so I had to simply take out like 6 of the screws, flip the webbing pieces over, and put the screws back in. But here is a quick assembly of a few more with the correct orientation of the plastic webbing. After the first one, it was a lot easier to just mass produce these things. So now I'm assembling a corner piece, which is a bit different. The way they designed it was actually pretty genius. You take a full 8-foot piece, you cut it at a 45-degree angle at the appropriate place, which is all outlined in the manual, and that allows you to get one full corner assembly out of two 8-foot pieces of foam. So even though it's like two independent 45s, they made it take up the same amount of foam as the regular straight assemblies. It's kind of hard to explain what I'm talking about since you can't see the full assembly yet, but in a minute I'll show you a zoomed out view of all of these foothold assemblies laying on the ground and how I plan to attach them together. But if you want to go online and look up the manual, you're welcome to do that. So here is what they look like, kind of laid out roughly, but before I move any farther, I need to take the blowtorch to this plant life. This is a simple propane attachment that we got from Harbor Freight several years ago, just for this purpose, but I have a little tin can stuck on the end of it to help us burn circular holes through landscape fabric. I just left it on there because I didn't feel like taking it off and losing it. This was the only time we torched this area. We kept it maintained just by some proactive weeding. So now it's time to put the corner pieces together, and I already have that interior string line to align them to. And my plan for the corners is to apply a piece of zip tape just to keep that foam closed and prevent a blowout. But obviously there's going to be concrete form stakes all over the place to control the elevation more than anything, but it's also going to help prevent blowouts in the corners. I'm not really worried about blowouts just along these assembled forms because the amount of webbing that's in there, every 16 inches is way more than necessary to prevent a blowout, at least for concrete of this depth. You'll get to see later on in the video, towards the end, how the concrete pour actually worked. It wasn't really clear to me what type of tape I should be using for these corners, but I opted for zip tape because it's a very good all-around tape, and it's definitely rated for exterior use, at least for 6 months exposure. That's what the warranty says for zip, and we have an entire box of it on hand because we're planning to completely sheathe our house with zip sheathing. And the tape is used to seal the seams together between the boards, which should keep moisture out of the house. But let's move on from the tape now.
We had a massive thunderstorm last night. It interrupted my progress. Fortunately, my table saw still works, but that wagon got filled up with water, and I got the table saw and the vacuum cleaner put away in my little garden shed over here while it was raining. I got completely soaked, and when we came out this morning, some of these forms had blown away. Thankfully, yesterday I had started putting a little piece of zip tape on every joint, and that was strong enough to hold everything together. The ones that I didn't tape, mainly the ones in that back corner, had blown away. So I just came out today after the Strawberry Festival down in Stewart, and I got the rest of these measured and put in place. I'm in the process of taping all the seams, but I don't want to waste too much time on that because the ideal way to weight these down is using those hooks on the bottom of the foothold form spreaders. There's 3 little clips on the bottom where I can hook the rebar, and the rebar is definitely heavy enough to hold these things down. So I'm going to go ahead and walk around with some gloves on because that rebar is pretty rusty and gross. And I'm going to lift it up and hook it onto each of these plastic pieces. And then I can take my measurements and double check everything without the risk of these things blowing around. And the goal is to have them stable enough to use the laser level. I have a rotary level that I can go around, put it on each of those form spreaders, and then I can start putting stakes in the ground to make sure that these are all the same level. They have to be the same height because when I screed this across, I want to be able to set my foundation on top of this footing without too much effort. And I'm going to be using ICFs, and they snap together like Legos. Those will sort of find a level amongst themselves, but I have to add globs of spray foam underneath to make sure the bottoms are level, and I don't want to waste entire cans of the spray foam. So it's important for me to get this whole thing square and level.
I don't really recommend a kilt as proper construction attire, but we just got back from a festival and I'm quickly trying to get the rebar hooked onto these plastic pieces of webbing just to hold down all of these form pieces. And I'm doing that before I tie the rebar together just to make things easier.
So what I'm planning to do is at every seam here, You know, I put a piece of tape, and if I cut some scrap sheathing, maybe just like a little splice block, a square, I can span plastic to plastic. And that's really the only place where I can hold it together with screws. A screw through the foam's not going to hold very much at all. But if I put these splice blocks on, then that's really going to make this whole thing one full assembly. And then I can put a stake right next to that block, pull the whole assembly up or down based on my rotary laser. And then once it's the perfect height, I can put a screw straight through into that block. Like I said, if I put a screw into the foam, it's just going to rip out. So let's see what I can get done on splicing this thing together. And then once I have the stakes in the ground, I can finally level the whole system, and then we can start getting closer to concrete pouring.
So this concept of these splice blocks is not outlined anywhere in the foothold instructions. This is something I purely invented due to my lack of experience pouring concrete. I just thought having the forms actually attached together with more than just tape seemed like a safe thing to do, and also I had some of this green zip sheathing around that was left over from the solar shed project. So I ripped it down, I think to maybe 6 inches, and then I'm cutting it into 6 inches again. So it's going to be like little 6-inch squares. And my plan is to put 2 little drywall screws into each piece of plastic webbing, and then it'll span across to the next piece of webbing, which will also have 2 drywall screws in it. And the intent of all of this, in addition to holding the forms together, is also to create a point where I can attach a stake to. Obviously, a stake can be screwed right into any of the plastic pieces of webbing, but then you have to use a bunch of stakes per form assembly. If I have a splice block connecting 2 forms together, then 1 stake can be shared between 2 of the foothold assemblies. I think that's going to save some stakes, and since the extra stakes aren't needed to prevent blowouts because of the webbing, then I might as well minimize the amount of stakes I need. And also, since this material is already sitting around and essentially free, why not just put in an extra hour or 2 of work just to make sure everything can be as strong and as level as possible. This all just made perfect sense to me at the time. Maybe there's different ways to do this. Your results may vary, so let's move on to the assembly of this system. Just to save some strain on my body, I'm going to go ahead and tack some screws into the corners of these before I move them down onto the foothold system. I actually had a few decking screws that were the appropriate length, and I prefer to use a Torx bit whenever I can, but I quickly ran out of these and had to switch to the drywall screws, which use a Phillips head. I'm not going to dwell on this topic for too long because I feel like I've sufficiently explained myself, but here's just a quick time lapse of me installing the splice blocks only in places where 2 foothold units meet together. 2 screws go into one webbing, while the other 2 screws go into the opposing webbing on the next foothold system. And this really makes everything pretty rigid, even though the rebar is already holding everything together anyway. But this is going to allow me to control the height of the stakes, which I am going to build next. I have some 2x2s around that I've been using just for some temporary bracing when I'm doing concrete work, such as building Cedar's playhouse and creating our garden rack. I'm just going to rip those down into 3/4 inch strips, and then I'm going to sharpen them into a point just to make a bunch of disposable stakes just to hold the concrete forms at the appropriate height until the concrete's done. And then I can just throw them away. They don't need to be reusable. In fact, I'm sure a lot of these are going to be stuck in the ground and not be able to be removed anyway, so I definitely don't want to buy a bunch of stakes just for this one-off use project. So the way I like to make stakes is to rip them first, cut them down to the appropriate length, and then just kind of freehand eyeball the point. I don't really want to take out a handheld saw. It's just a lot of weight on my body. It's easier for me to just keep the table saw running without any sort of guard on it, just because I have some experience and I'm not too concerned about the safety. And then just, freehand those cuts. Cut the square corners off of the ends and just sharpen it to a point. Now the stakes are done, and it's time to start hammering them into the ground so we can control the height of these forms. And that brings us back to the splice blocks. Just like I said before, a stake is shared between two of these foothold assemblies because I'm going to attach them only to these zip sheathing scraps, which are the splice blocks. So I throw two stakes at every intersection between the foothold systems, and then I drive the stake, and at a future time, when we have the rotary laser out, I can actually pull the formwork up and down and then put one 3-inch screw through the stake and into the splice block. And that was really just a proof of concept. I do like the splice block idea enough to continue making more and put them at every joint. So that's what I'm doing now. I don't really have anything technical or impressive to say about driving stakes, other than make sure you use a real mallet and not just a framing hammer. Our soil here is pretty well compacted. This is undisturbed soil, which is what the code requires for your footer to set directly on, unless you have some sort of engineered backfill. In that case, you need to follow the instructions exactly how your engineer dictated. But for us, we're just hammering regular stakes into regular compacted ground. I'm not using a level or anything like this because footings don't need to be precise. The formwork is going to do most of the work here. These stakes are really just to control the height. So I'm eyeballing it and trying to run the stake perfectly vertical along the splice block, which actually serves as a very good guide to estimate vertical. And then I'm just working my way around this, trying to slide the formwork in and out to match where the string line is, and then drive the stake, which is going to lock the formwork into its permanent location. And just because of my inexperience, I'm going around with a sledgehammer just to make sure that these stakes are finished off and they're not going to move at all. I'm sure the handheld mallet was perfectly fine, but as usual, I'm just spending a few extra minutes for that extra insurance. And now it's time to tack some screws in place and prepare for the leveling. I have the rotary laser set up on a tripod just outside of the camera frame, and I have the receiver here attached to this stick that it came with. It actually looks like a really long extendable ruler, but what that allows me to do is pull the formwork up and down until I get a solid tone on my receiver. That tone indicates that it's exactly within the horizontal line that the rotary laser is projecting from the tripod. As long as nothing moves the tripod, you can continue to work your way around your entire project space, making sure everything is nice and level. You can't really see the laser unless it's nighttime, but the receiver has an audible tone that allows you to know whether you're in line or not, and it also has a blinking arrow that points up or down to tell you which direction to go. So as long as you're close enough to start with, you can rely on the tone or the visual cues of the lights. So the formwork is all nice and level now. It's in its permanent location, and the stakes are holding the splice blocks exactly where they need to be. Now what we need to do is shovel a bunch of this washed number 57 stone over to the side of the formwork so the concrete can't pour out from underneath it. It's actually pretty high off the ground in some areas just because I'm not a professional when it comes to excavating. A lot of the formwork is pretty close to the ground, especially in that back right section of the frame. But right here where I am now, in the front center of the frame, there's a pretty deep area that needs to be piled up. Honestly, I don't think it's going to make much of a difference if some of this stone trickles down underneath the formwork and gets in there, because concrete has aggregate in it already. It's actually made out of stone. And also the formwork is way oversized for the code minimum requirement for the size that our footer actually needs to be. Our footer is going to be 20 inches wide and probably 10 inches deep in most places, but code only requires this 2-story house to be on a footer that's, I think, 16 inches wide and 7 inches deep. So yeah, way overkill. If we have some issues, it's really just going to average out and be totally fine. So yes, this is a lot of shoveling, and it might have been easier to just bring in an excavator and a fresh load of stone afterwards and just pour it all with a machine. But this was just like an hour or so of shoveling. I got it done, and now there's no way that the concrete can pour out of the formwork. One obvious fact I haven't mentioned is that I did have to do this on the outside of the formwork and the inside of the formwork because we don't want concrete blowing out on the inside in the crawl space either. Speaking of the inside of the crawl space, we have to form out the pony walls as well. These pony walls are a interior footer that's not going to have the insulation that the foothold system provides. We're simply going to use some 2x8 lumber that can be reused later on as floor joists for the second floor of the house. But before I can put those in, I kind of need to get the rebar and the string lines roughly in the space that it's going to be. And to elevate the rebar off the ground, I'm using these little rebar chairs, which hold the rebar, I believe, about 8 inches apart. And that's an appropriate width because you don't want the rebar too close to the edge of the formwork, because you don't want it to be exposed to the air after the concrete cures. You also don't want it touching the bare earth, so it's important to elevate it up. There are plenty of engineered instances that could eliminate these pony walls. You could have some sort of engineered floor truss system or maybe some LVLs that can span all the way across. But to keep our lumber small, since I'm building this myself, we have to keep our spans short. So we have to create these concrete pony walls to support the joint between the floor joists. This is about a 36-foot long building, and our joists are running that length. So instead of a 36-foot engineered solution, we're doing several shorter spans. I have all of the rebar tied now, so here's a zoomed out view of what all the rebar and the formwork looks like in its appropriate places, minus the wooden formwork that I just explained. But as you can see, our footing form is taking shape, and we're getting closer and closer to concrete. All we need to do now is set up those wooden forms, spray some form release on them, and get our footing inspection before the concrete truck comes.
We really need to finish up the formwork and the rebar so we can get this project inspected and pour the concrete before we start having more plant life grow in these forms. So as you recall, our form consists of the foothold system, which holds the rebar up instead of rebar chairs. It holds the foam board as a form instead of using removable formwork. And then it's also insulating the footer. So let me try to get in here to show you what we need to do next. The concrete is only going to be poured to this level here. And that's about 2 inches lower than the top of the foam. But we need to get vertical rebar dowels. So when we put the insulated concrete forms on top, they'll slide over vertical pieces of rebar. Those insulated concrete form blocks are 16 inches tall. We're doing 2 courses, so that's 32 inches. So obviously we don't want the rebar to stick out of the top. It would be in the way when we go to put the mud sill on. So I probably want to leave that about 2 inches below the top of the concrete. And so that would be 30 inches, but I can't just freely have them suspending here. I think I need to bend them like an L shape and tie it into the existing rebar. And that rebar is located about 6 inches below this. So if it needs to be 30 inches above this and 6 inches below this, that's an even 36 inches. So that's 3 feet on the vertical part of the L. And then the horizontal part of the L, I guess it doesn't really matter exactly how long that is, as long as it's long enough to put some rebar tie wire around to attach it to our existing formwork or foothold or whatever we have down there. It needs to be able to be supported so it can stand upright, so I'm not placing dowels into wet concrete. The professionals have experience to place things in wet concrete. I feel like, since I'm new to this, I want to get everything rigid and locked in place and tied. So when we pour concrete, it might be a bit wobbly and I might have to make sure things look exactly perfect, but at least they're not going to move around too much. So I'm going to get the rebar cut and bent now.
And I'll try to explain what I'm doing as I go. So just like before, when I was cutting the angular rebar pieces for the corners of the footing, I am taking my angle grinder, cutting these off into appropriate length, so then I can bend them using the same techniques that you saw before. These ones need to be a bit more precise because I don't want them to be too tall. So I'm putting my tape measure through this hole with the rebar, and I'm bending it at exactly 1 foot. And with a 4-foot piece of rebar, that means there will be 3 foot vertical and 1 foot horizontal. And now I need to figure out how to actually attach this. I'm going to start in the corner because it seems like the easiest space with the most room to manipulate this. I don't have a lot of experience using tie wire, but I'm just going to see what I can do with a pair of pliers here. My immediate idea is to try to prop it up with the plastic webbing on the foothold system. So I can get one piece of tie wire on the vertical, and then where it hooks down, I should be able to tie it to another horizontal piece that's already there. Obviously, these are a bit finicky. It'd be nice to have an extra set of hands, so I'm going to see if Angie will help me going forward, but I just want to establish a proof of concept before I ask for help. All right, the proof of concept has been established. I'm going to go ahead and bend the rest of the rebar that I need for these vertical dowels. It's going to be the same L shape as you've seen before, where it's 36 inches tall and 1 foot horizontal. I'm going to quickly bend all of these and make a nice stack. I have to try to be pretty precise and make these as close as I can to 90 degrees. That way they're not going to need as much correction after the concrete's poured. Here's a close-up of the L-shaped vertical rebar dowels. So just real quick before I ask for Angie's help, I need to actually establish layout marks on the foam using a tape measure. I need to figure out some sort of logical layout because the foundation wall is going to be made out of Fox block insulated concrete forms, and their manual is pretty specific regarding where the vertical rebar dowels can be. They have webbing every 8 inches, and the vertical rebar cannot conflict with that webbing or else I'm going to have to cut it off. And another thing to consider is that the vertical rebar dowels cannot exceed 4 foot on center spacing. So with all of that in mind, every time we place a piece of rebar, I'm just making sure it's less than 4 feet, and then I measure in both directions to make sure it's not going to conflict with the webbing in the Fox blocks. It's a bit tricky to explain how I do this, but I essentially pre-marked on the foam where the edges of all of the Fox blocks are going to be. And using the instructions that Fox blocks provides online, I'm able to forecast where the webbing is going to be and simply avoid it with the vertical rebar. If a piece of rebar was going to encroach too close to a webbing, then I simply move the piece of rebar to the other side of the webbing in the foothold system. That essentially shifts it like 1.5 inches to one direction, so it should pretty easily clear the webbing on the Fox blocks. I really have no idea how the professionals do it, but I'm comfortable doing math and using a tape measure, so doing that extra bit of work I think is going to make it worthwhile, so we don't have to remove any of the vertical supports and potentially have to drill through the footing and install new ones. So now it's time to do some traditional concrete formwork with dimensional lumber. I was saving this till the very end because we need to salvage this lumber for the house build, and I don't want it sitting outside too long and deteriorating in the weather. So as you can see, I'm putting the 10-foot pieces in first, whole, and then I think these are 12-footers that I'm butting up to it and tracing a line where the cut needs to be. I have all of my framing done in SketchUp, and I was able to determine where exactly these can be used to make sure that when I chop the ends off of these longer boards, they're still long enough to use. But once I get the seam lined up, it's just a matter of aligning the boards with the string line and installing a few concrete form stakes. I have a lot of these stakes left over from previous projects, and they actually come in handy. They're round and they're very easy to drive, and because they're round, you can kind of spin them in order to loosen the grip from the earth to remove them. And there's holes all over the place, like every 2 inches, so you should have no problem fastening it to your formwork. Before I screw them into the formwork, however, I have to make sure they're level. And I'm actually using a traditional level because I know that the formwork from the foothold system is level, and I just have to make sure this corresponds with the top of the webbing of the foothold system and level it all the way across. And finally, similar to how we finished the foothold system, we need to backfill just a little bit outside of the forms so there's nowhere for the concrete to go if it goes underneath the formwork. Here we go. One hand here, way over here. Scoot, step over here, there. Put your other hand up here. This hand here, that hand there. There we go.
No.
You have to push it down so it can go through.
hole.
So it's been a struggle trying to find a place where Cedar can be involved in this project. Usually what I'm doing either requires too much precision, sharp materials, or power tools that I don't want him to be around. But this next phase involves simple placement of anchor bolts, and I just have to create this little jig where I put the bolts in a 19-inch long scrap of wood. So he's helping me drill the holes and place the anchor bolts inside. Angie is then going to place a nut on top so these can't fall off, and then Angie and I will put them in place so these will be cast permanently in concrete. One thing that wasn't really clear to me about the foothold system was how to handle intersections. This is probably the easiest intersection because it's 90 degrees, so everything is pretty square. The problem I ran into, though, is that the webbing on all of these intersections for the pony walls falls right inside of the pony wall forms. I don't think this is actually going to affect anything, but I have to be careful not to compromise the webbing because the foothold webbing is what acts as a spreader cleat and prevents blowouts when the concrete starts pushing outwards against the foam. I'm gently carving a rectangle out of the foothold system, so when we pour the walls, the pony walls and the perimeter footer walls will be one and the same. There's even rebar bent that's passing from one section to the other. And now that I have these rectangles cut out, I can finally elevate them using the rebar chairs and finish the rebar tying. I'm not 100% sure if this little 2-inch strip is required. I left it there so as not to compromise the strength of the foothold system, but I think that the webbing does that job just fine. I just left this on there because it doesn't really hurt anything. Let me know in the comments if you've done intersections before on your foothold system and if you left this strip or not. We don't actually need this top 2 inches of foam at all because the concrete's only going to be poured to the top of the webbing. I think this extra height is designed for people that want to do a monolithic pour where the footing and the ICF foundation wall are poured at the same time. And you can actually add more foam on either side of where the ICFs are going to be. That way there's nowhere for the concrete to come up out of the bottom of the ICFs. But I just left everything there because there wasn't really a separate instruction manual for people using this for just a footer. If I was a professional and I had opportunity to try this multiple ways, I definitely would, and I would definitely take note of the best way. But for now, I'm just playing it safe, and I'm only removing the material necessary to allow the concrete to flow around the corner. So anyway, back to the wooden formwork for the pony walls. You can see that I'm using a carpenter square to transfer the lines across from one board to the other. And that's going to show us exactly where the anchor bolts need to go to hold the mud sill down to the concrete wall. We don't have these on the perimeter wall because ICFs are going on top and then the mud sill will go on top of that. But since we're not using insulated concrete forms on the pony walls, I need to bolt down a mud sill that will then support a very short, like 3-foot wall that's going to carry the loads from the first and the second floors all the way up. You should check your local code to find out the appropriate spacing for anchor bolts, but generally speaking, there needs to be an anchor bolt within the last foot of every board being bolted down to the concrete, and the interior spacing can't exceed 6 feet. I'm actually going to leave out the center stud and put a small header over it so I can retain access across the entire crawl space. I prefer wet setting my anchor bolts, but I'm using these little jigs to hold the anchor bolt exactly where it needs to be so I don't have to place them in the wet concrete later. Now for the moment we've all been waiting for. All of this work over the past few months, dealing with the weeds, trying to lock down these forms so they can't blow away, trying to keep the wood salvageable so it doesn't rot before we can hide it away for the house. It's finally time to pour the concrete. Thankfully, according to my calculations, all of the concrete we need for this can fit easily on one concrete truck. I ordered 8.5 yards, and that includes some buffer that I calculated in. I think about 10% just in case I miscalculated. Keep in mind, we do have a lot of low spots that makes it increasingly tricky to compute the actual cubic feet or cubic yards that are needed for this project. We like to get all of our concrete locally, just at the bottom of the mountain from Stewart Concrete. The driver is excellent. He's able to anticipate our speed, our skill level, and he's able to explain to me the best way, in his opinion, to approach this. Thankfully, I left room on all sides of this project so he can easily drive the truck all the way around. But all we really need to do is access this build from the south side and the north side. That's the long walls, because his chute is long enough to get just about halfway across the short walls. So our plan was for him to go around a couple times because I wanted to fill up the outer walls first, which is the foothold system, and then come back and do the pony walls. That's just another idea I had because of my inexperience. I wanted to make sure that the foothold system was completely full, and if we had any shortage of concrete, that would just be down in the pony wall, which then we could fill up using bags of concrete and my personal concrete mixer that we have here on the homestead. But as you'll see pretty soon, there was plenty of concrete to fill everything up, and I even formed out this little pad for a small slab that's going to be under the trapdoor in the pantry that'll allow us access down to the crawl space. We really have no requirement for that. It's not structural at all. We're planning to have vapor barrier down just to kind of keep everything clean down there. And maybe we'll want to throw like some totes of potatoes or other vegetables down there, like a root cellar. It's nice to have a small pad so we don't have to stand on gravel and potentially puncture the vapor barrier. Keep in mind that this crawl space is going to be fully conditioned. It'll have its own dehumidification and climate control system, and it's going to vent into the living space. There's not going to be any access from the outside of the house, and that trapdoor from the pantry will be the only way in and out. I can't say for sure how often I'll go down there, but at least during the build, I think that little slab will come in handy, but we can focus on that in future videos. Let's get back to how the concrete pour actually worked for us. So while I was explaining all of that, I was using just some drone footage, but this is the same footage but from a different angle. I actually have a tripod with my GoPro on it up on the second floor of Cedar's playhouse. So I just want to explain a bit about what Angie and I are doing. We each have our own dedicated tasks. I'm responsible for communicating with the driver, moving the chute, and aiming the concrete. And as I signal him to stop the flow, I'm able to pull the rest of the concrete out of the chute and shovel any high spots into the low spots. Angie is using this electric concrete vibration tool that we ordered from Vever. I have no idea how we could have done this without that tool. I can't exactly rake the concrete in the traditional sense because of all of the rebar and the webbing that's in the way. But because of the vibration tool, Angie's able to settle the aggregate and allow the concrete to flow from the high spots into the low spots. And as we move farther and farther down, sometimes I have to go back and throw some concrete into spots that sank too low, but that didn't happen too often. But like I said before, the concrete driver was very good at anticipating, and I probably had to do half as much signaling as would have been otherwise required. Now you can see we're done pouring the concrete. He's actually cleaning his chute in an area that I reserved for him, but I'm trying to do the final troweling. We don't need any special finish on this because it's just going to have blocks on top. All I care about is it being level. But we're really racing the clock here, and we found that there were several high spots that really needed to be shoveled off, not a simple trowel finish. So I'm doing my best to get all that concrete off. You can see right here it was like the highest spot. So I'm shoveling off a bunch of the concrete and throwing it down. You can tell it's high because if you have a small trowel and you dig down to the webbing, there's about an inch of concrete above the webbing. And I used the webbing with the laser level to establish the grade.
All right, YouTube. That was a lot of work. That would have been impossible without Angie's help. Excuse my out of breathness. I'm so fatigued. I took a shower, lay down for a bit, had some food, trying to stay hydrated. It doesn't look perfect, but this is never going to be seen. This is actually going to be below grade once we backfill. I'm not too concerned about it. The foothold system worked miraculously. We have minimal stakes. I only put stakes on the corners and on the seams
between, I guess, where two foothold assemblies meet. I guess because the foothold system has so many of those webbing pieces on it, the concrete is not really at risk of blowing out. But as you can see here, we had enough concrete for the full perimeter, for the 2 pony walls, and for a unplanned slab that we just kind of threw together last minute. We threw some random rebar scraps in there as reinforcement, and I used some old scrap lumber I had lying around. That's going to be where the trap door accesses the crawl space from the pantry floor. That's not really needed. I was planning to just lay some extra zip boards or some other plywood type material down there on top of the vapor barrier once we get that installed. But we can have the vapor barrier go right over that slab, and then that'll be kind of a reinforced area if we ever need to put a step ladder down there to get through the hatch. That would work. Oh, but man, that concrete was curing before we could finish. So basically this 26-foot wall right there, and then probably the last third of this wall here, we didn't get to really screed it down with the trowels before it cured. So those are a bit high. I might have to grind them down with a diamond cup wheel, which I have already, but I think what's more likely is that I could shave off the bottoms of the Fox block ICFs that we're going to use. Since they're made out of styrofoam, they should be pretty easy to cut. Anyway, that's it for this video. I'm so fatigued I can barely hold my iPhone up. So if you want to know more about this process, ask us a question down in the comments. If you want to see more steps and how owners like us can build our own house with no house building experience, go ahead and subscribe, and we'll see you back here next time on Kind Heart Homestead. Thanks for watching.